I believe generative AI has the ability to transform the way we operate and process information and data across the energy industry. It has the ability to accelerate the rate at which we do analysis and make decisions in an informed manner. And in doing so, accelerate not just the evolution of the energy industry, but the energy transition as a whole.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to another edition of the Insider's Guide to Energy. I'm your host, Chris Sass, and with me as always is Jeff McAulay, our co-host. Jeff, this week we have Akash Sharma with us. It's going to be an interesting show. We're going to talk AI.
Akash, welcome to the show. We're very excited to hear more about Enverus and AI impacting the energy industry. First, just to start us off, can you tell us a little bit about your role and what you're doing at Enverus?
Absolutely. First of all, thank you so much, Chris and Jeff, for having me on the show. As somebody who's listened to quite a few of your episodes, I look forward to the opportunity to discuss and talk about this really interesting and exciting, position we find ourselves in. So a little bit about the company first. I work for an organization called Enverus. It started in 1999 in a variety of different iterations. And as of today, it is the largest and amongst the fastest growing energy-focused SaaS companies in the world. Right? We pride ourselves in providing end-to-end data analytics and solutions targeted specifically at the energy industry. So spanning from oil and gas to renewables to power, as well as back office operations and consulting and data science in that sense. I personally, my role officially is the director of product innovation, which is a lot of fancy word to say. I get to work with teams across the entire organization to find where new technologies and innovative solutions can provide the most value. So over the last decade or so, I've worked with different teams, different product parts of our organization to look at new trends, emerging technologies, and see how they could fit into solving incumbent challenges or sometimes discover new step change solutions.
Recently, there's been a lot of talk with AI. I started the show by introducing you and saying we're going to talk about AI. And you said you get to look at the technology and where it applies to the business. I guess it would make sense is to start out, what kind of AI are we talking about? Are we talking about the generative AI that we talk about? And what's the impact that it could have to the business?
I think that is a great question. I think more often than not, when I talk to peers and customers, there's a big confusion about generative AI or AI and like all these things where it fits. I think AI as an application in the energy space has existed for decades, right? None of this is new. The first neural networks, which are the foundational blocks of what is now generative AI, was written in the 1960s, right? I think there are a few very fundamental market events that happened in the last few years that have led to the revolution we are seeing right now. And we can talk more about those as well. But a core focus on what my team is working on right now in our organization is the generative side of AI. There is a bigger team that works on other applications, and it's almost interesting to call something standard AI, but traditional technologies and innovations. But my team specifically is looking at, is generative AI something that can be looked at from an industry and enterprise application perspective?
That's great. And what kind of data sets are you analyzing? There's a lot of data out there. I think everybody's now familiar with the chatbots, text-based analysis, looking at PDFs. Is that one of the primary applications, or what types of data sets are you actually pulling into these models?
Absolutely. Yeah. So, when we first started looking at generative AI and its application, it started off with, as you mentioned, the chatbots and chat GPTs as this, how can we leverage this information to support in those sort of applications? Because with the sort of widespread usage of chat GPT, that sort of became the incumbent way of processing these details. But when we start to look at it from an enterprise perspective, we realize that the potential of generative AI is actually far more outreaching than as a chatbot itself. Having said that, some of the early work we are doing is in that area because, in technology, as I'm sure in other industries as well, there is a concept of minimum viable product. So you always start with something that can define core value, and then you expand from there. But from a data set perspective, we are now operating in a space where we're dealing with large quantities of unstructured and structured data, as well as geometrical information, relational databases, multimodal images, graphical information, all of those, right? There is varying degrees of complexity and varying degrees of success that comes with each of those data sets, as you can imagine. But the framework and the technology itself is capable of handling all of those types of data.
When you talk about model, there's a lot of there's proprietary models. You mentioned OpenAI. There's open source models, uh, Llama, or some of these other ones. So, are you trying to train new models? Are you building customization layers on top of existing ones, or working with open source? Tell us about that tech stack.
Absolutely. Yeah. So I think when you look at all these different models that exist out there, uh, there are sort of 4 or 5 different ways you can look at implementing generative AI in your industry, in your space, right? As you mentioned, your custom models, whether it's OpenAI or Anthropic or Llama, they're getting increasingly close to each other, right? When they started off, there's probably a bigger gap, but they're increasingly becoming the Olympic 100-meter final photo finish type models. So that is a core part of our sort of tech stack that we do use. We are also looking at building foundational models from scratch. Of course, those have to be very careful with our use cases. As you can imagine, they're very, very compute and cost prohibitive when it comes to building those. But there are certain use cases where that makes sense. And fine tuning is also something that we're looking at on a case by case basis. Another thing that's starting to get talked about a lot, which has become a core foundation on how we are looking at these systems, uh, has got to do with the agentic frameworks, right? So, how do you take a particular model and data set combination and wrap it into an agentic container? And how do you chain enough of these tools and agents together to create you know, a truly valuable workflow from a business and enterprise perspective? So we've got different initiatives in each of these buckets. Uh, but we started off, of course, the first one was using a foundation model, building a RAG framework around it, and seeing what value can be brought from that.
So let's get specific about an application here, because I'm at the level of throw a PDF into a custom GPT and ask the document question. So that's out there, that's easy, that's free or near free. That's not what you're talking about. What specific applications, or you talked about an agentic framework. What is that agent doing, and who are they doing it for?
Sure. So I want to start off with actually, if you don't mind, with the example that you just gave, right? Which is you take a PDF, you drop it into a model, and you see the response you get. That is a really that is a great workflow. I like that workflow because it allows us to unlock the potential of unstructured data that was usually hard to capture. We would convert unstructured data into structured, and those sort of tables to get. The first step that goes from that sort of a workflow to next would be actually scaling out RAG itself, right? Retrieval augmented generation for generative AI is what regression is to machine learning models, right? What I mean to say by that, it's pretty easy to put together the first model, but to truly build a good, strong regression model, as well as a truly strong, reliable, and scalable RAG is just as hard. So, as an example, the first RAG that we built was a product that is now out there called Instant Analyst, and it was the first generative AI based product out in the energy industry, and one of the very few that have truly existed on an enterprise level so far. The primary reason behind that is if you want to expose something externally outside of your organization, there's a lot of data orchestration that needs to happen. Because in your use case where you ask the model to give answers from one PDF, it's relatively straightforward because the model will vectorize that particular PDF. But if you're asking it to answer a question from, let's say, a repository of 150,000 documents, that gets really tricky, right? Because now you're in the millions and millions of tokens. Finding relevance for your question becomes complicated. And if the objective of these models is to assist you in decision making and helping you make the best decisions faster, then creating an orchestration system that makes sure that the most relevant information actually percolates to the top can be really difficult. So, advanced RAG is an example of a workflow that we have done a pretty good job at with the Instant Analyst product and has seen really, really strong results. But that's one example of the workflow.
Can you be more
How,
specific?
how does someone, hold on,
Yeah.
Jeff, how does someone interact with instant analysts? So let's get a little bit more into, I mean, the name sounds like, I click on something and it all happens really easily. How does my organization work with it and what does it do for us?
Absolutely. So, Instant Analyst was being our first product, as I mentioned. We started off with the paradigm that already exists. It is a chatbot that is connected to about 150, 160,000 research reports that our SEC verified research arm has written. Right. So they write research about energy trends, energy equities across the board, and this model connects to that. Your method of interaction with it is a chatbot that either exists within our platform or as an app that's out there on iOS and Android, and all you go in there is ask questions and you get answers. Now, where we delineate ourselves from, you could say like, hey, I could ask the same question to ChatGPT, right? I could ask the same question to Gemini. Where Instant Analyst truly delineates ourselves is A, by quality. I am not sourcing the information from the internet, right? Where really high quality research could be weighted equally as somebody's blog about that subject, right? And secondly, by minimizing hallucinations. There's a huge amount of focus in our process to minimize hallucinations because there's a much smaller tolerance in hallucinations and errors when it comes to B2B applications versus a B2C applications. Like I would be fine with my, cake recipe from ChatGPT being one egg off, but if it gives me wrong metrics for production numbers, that's a whole different paradigm, especially if I'm making business decisions on that.
Okay, so you have a contained data
Mm.
set or a better data set. You've got some safeguards or safety rails to de-risk some hallucinations. And from what you said, that sounds like the 1.0 version of the code. So that was your first
Yep.
product. Let's turn the clock ahead to 2024, where we sit today.
Yes.
Where's the industry at today?
So the industry at today is so the areas we're investigating is what Jeff brought up earlier was the agentic frameworks, right? Like so you have the 1.0 product, you want to continue to get that 1.0 to 1.1 and 1.2, and that effort is going on. But what's the 2.0 solution? So the 2.0 solution is our multi-agentic framework where we believe that the way we are designing these things will fundamentally change how a user interacts with business intelligence products and suites. So what that means is, as an example, if you're trying to figure out some geospatial analysis of wells in a particular area or parcels in a particular area that meet certain criteria, as a user, as an engineer, you do not have to speak the language of computers. You can code, so to speak, in English and give it your business instructions. The instruction that you give it gets broken down into specific tasks, and then those tasks are passed on to specific agents. And this is the power of the multi-agentic framework, in which each agent is essentially its own LLM and data source model. So imagine if I'm asking, give me all the parcels from a particular substation or LMP node that meet certain criteria. Then one agent's job is to figure out where is this LMP node, right? Second agent's job is to figure out what does this radius mean. Third agent's job is to figure out what parcels contain this, right? Another agent filters that. So as you chain enough of these processes together, it allows you as the user to focus on the decision making involved in building and developing these projects and less about how do all these pieces orchestrate, how do I manage these data sets, what are the different IDs and systems that connect to each other. That is the general thesis of the 2.0 project, and that's what we are working on right now.
Akash, how do you deal, or how does the system deal with conflicting information, either things that are out of date or across purposes? So in the instant analyst example, it could be we've got the last 30 years of EIA projections. Everybody knows that those are famously off by significant amounts. Does the system in the instant analyst example understand to weight more recent data more strongly than old data? And then similarly, it sounds like you're getting into a infrastructure citing example. Well, one agent says, yeah, this is a great parcel because it's got high LMP. And the other agent says, no, it's a terrible parcel because it's in a floodplain. And they disagree. How do you resolve conflict between agents?
Yeah. Absolutely. That is such a great question because that has been such a core part of when it comes to information extraction to what is delivered, right? So let me talk about the date part first, and then I'll talk about the other one. So when it comes on date, understanding the different dates and conflicting information, that is almost where that is the part of the RAG system where what's the difference between a basic RAG and an advanced RAG, right? Those are the retrieval and processing systems that we've built that allows the model to understand these things. So I'll give you an example of how you could build this is uh, you could tell the model that you will weight newer forecasts better than older forecasts unless specified by the user, right? So unless, Jeff, you say, hey, compare the forecast that was generated in 2022 versus now, and maybe there was a bluebird event in 2023, so you rely on that forecast more, you can give this specific instruction. Now in a standard RAG, this won't really matter because all you're doing is a vector similarity search, or you can come up with a fancier search algorithm, but it's basically a similarity index. But in an advanced RAG system, you can again break this thing out into specific instructions, right? And give the model very specific instructions on what to do with what data set, right? And so with these instructions in mind, in our instant analyst product, we tend to prioritize newer information more, especially when it comes to market outlooks, again, unless specified by the user. Uh, when it comes to conflicting informations completely, that gets really interesting. In the example that you mentioned, whether you have an agent that's pulling and it's evaluating on certain criteria, and the other agent that's evaluating on another criteria, uh, it sounds it sounds a little funny, but the answer is actually yet another agent whose job is to do this evaluation, right? And we've given it certain evaluation metrics to for the model to not necessarily just be like, you gave me a question and I'm just going to give you an answer regardless. That's not our priority. I would rather the model come back to you, Jeff, and say, hey, I'm getting this type of results with these criteria and this type of results with this criteria. Hey, Jeff, you are the expert. Which criteria do you think is better to use, right? And again, all of this interaction that you're doing is in English. It's like working with an intern or a junior analyst that kind of already knows your data schemas, already knows a lot of the logic, but maybe does not have the experience and understanding and the nuance of how these data sets interact with each other.
How much learning takes place in that example? So, as does it get to know me? Kind of as I ask prompts and study things, does it get to know what I'm kind of thinking? Is there any learning on your side, or is it always a blank slate when I start?
Uh, Great question again. So there is this concept of a semantic learning process where you can create a repository of, hey, these are the kind of questions Chris likes to ask. And when he usually talks about these things, or when Jeff talks about these things, prioritize exclusion layers over LMP pricing or whatever, right? That is something that we haven't built into our system yet, but that is something that you can build. From more so a ongoing learning process, there are pros and cons associated with it. So the primary reason behind that is like, it only works if that version of this enterprise product only is connected to you, right? Because what I don't want is uh, one user giving so much of specific instructions that the experience changes for another user, right? And similarly, taking that continuous user input as a retraining data set is not necessarily always a good thing. So because it could be continuous amount of errors, that could be user error or lack of data that getting trained into the model instructions could lead the model to behave weirdly. So the way we are currently handling that is we work with customers to understand what are the kind of questions it's doing a good job at and what's the kind of questions it's not doing a good job at, and then we go back and then we create additional instructions, system prompting, if we need to add a fine-tuned node on top of it, things like that, to solve thematic issues, right? But we are looking into creating a semantic add-on where Jeff's version knows what Jeff likes to answer, and Chris, your version knows what you like to answer.
Can you talk more about how you do QA on something like this? Because
Mm-hmm.
we're experimenting with this as well. Great, agent, go comb through these 1,000 documents and tell me the following information. We get it back. We're like, great. Who wants to check the work of the AI agent to see if it was right or not? Because
Absolutely.
right, and it's at least nice that you mentioned you're mitigating hallucinations and it can come back and it can show references, but there's still a trust issue there. How do you deal with that?
Uh, it is not easy to evaluate generative AI models. like whatever answer I give you, that is a fundamental truth of these, right? They're just not easy to evaluate. There is a true cost associated with getting these models to a place and getting these solutions to a place where they're reliable. From a trust standpoint, there is also this idea of there being an AI model, right? Like, I don't know the stats on the top of my head, but the amount of accidents on US highways every year are astounding. But the Tesla auto drive car crashes once in 100 experiments, and it's like nobody trusts the autopilot again, right? So there is definitely some apprehension about errors, especially when generated by AI. The way we are trying to handle it, and again, we don't have the solution yet, is it's a lot of effort, rigor, and things of that nature. But coming up with metrics like, is this answer grounded in truth, right? So you essentially have to create an entire evaluation framework, which can be cost prohibitive because you're asking different models and other agentic workflows to test these things out. So if you ask a question that contains, let's say, 20 factoids from 30 documents, you have to then look at that answer and source corpus pair of information as now your test case for your evaluation protocol. So you'll do spot checks on different data points. Do these data points exist in both sources and answer? Do they exist within the same context? And then, do those evaluations and get a scoring metric out, and then scale this across so many different questions. One of the things that we've also done that has helped, and Jeff might be helpful since you guys mentioned you're looking at this as well, is looking at, it's almost like sensitivity analysis with numerical information, but how much does the answer quality change if I change the question slightly, right? Just different iterations of the question. What are the areas where you're getting some bleed in quality, things of practices of that. This is not an exact method or an exact science, but that is something that we continue to work on.
Your answer, though, makes me wonder. It still seems like we're using a human to machine interface as opposed to a machine to machine interface in your examples. So, are you seeing these early use cases generally a person going into an app, or are you seeing APIs from applications making queries out on behalf of a workflow or a process?
Yeah, so we've seen both of those cases. I think at the end of the day, wherever this information flows to before a decision is made, right? We usually want a human in the loop in that. Given the non-deterministic nature of these models, you do not want them directly hitting an API and making a decision, right? You don't want this models, the analysis that comes from these reports to trigger a trade, for example, right? Like you don't want that. So what you want is the trader to be able to get answer from 100 research documents in 15 seconds, that answer be as close to the ground truth as possible, and the trader to then make the most informed trade possible, right? But we've had some API calls that have more to do with some of our customers creating their own enterprise solutions. So they'll have their proprietary data. They'd want to connect to our solution set through an API endpoint, create a more automated chain of events. But there's always human in the loop in any of the test cases we've done so far.
Got it.
Akash, I'm wondering if we're heading towards some sort of AI moment that we'll call a Kasparov moment, right? So when Deep Blue beat Gary Kasparov in chess, this was a highly visible, easy to recognize moment when a machine had surpassed a human. And maybe in some applications that has clearly already happened, meaning having it read a 100-page PDF and come back with an answer in seconds. Okay, so that's already happened. Is there an energy specific application where that will be noticeable? Anything you think comes to mind?
Yeah, I think it's the energy industry and the energy space is so multidimensional and so complicated that it's hard for me to give a Kasparov moment. I think there are some big goals that we are going towards that may have, as you mentioned, like a couple of these moments may have happened, a couple more of them may continue to happen. I think our goal at the end of the day is that if you are somebody in the energy space, in any of these energy domains or in the energy transition space, and you're trying to make decisions, you're trying to leverage all these different data sets, you are able to make those decisions in the most informed way in seconds and minutes, not hours and days, right? And I think that level of efficiency and adoption, I think would unlock efficiencies for the way we do these transitions and we develop energy that could be considered as a Kasparov moment. I apologize, I don't think this is exactly the answer you might be looking for, but I think there might be a lot of these smaller events that lead to an overall sort of integrated solution.
So that brings up the question in my mind of how efficient, or how do you know this is bringing value, right? I mean, so I've had analysts all along, they go out and do this research, they come back, and you're very confidently saying, look, I can take this huge corpus of data and I can give you quick answers. So how do you determine how much more efficiency or how much better my organization's doing with this kind of a system in place?
That's a great question. So with the Instant Analyst product that we have out right now, we've done tests with our groups of users. Not all of them, but we've done tests with groups of users, and we still did a lot of blind tests early in the development, where we would say like, all right, this is what I want you to figure out. One team uses the analyst solution. One team uses just the regular find the report within the repository, and we've seen up to 80% improvement in productivity and efficiency in finding these answers, right? So as an example, something that would take 30 minutes in finding through text search, reading, researching, right? And then coming to the answer, the user is able to get to 80% of the answer in 7 seconds, and then spends about 5 to 10 minutes, validating, confirming, making sure that the answer is exactly what they're looking for. But that's a huge improvement from 30 minutes, right? And that those are the kind of tests we've done in the current example, right? We'll continue to do these sort of test cases as more and more more and more things come out. But any products that we build in this regard for the energy industry have to meet one of sort of three principles of product design. One is it should make you more productive. It should make information and tools more accessible, or it should make things more customizable, right? And so those are the different metrics that we try to capture in one way or the other. And so some of the metrics that I just mentioned, those are more on the productivity side.
Does this risk becoming a crutch for some analysts along the way? Or, I mean, if I look at the CrowdStrike moment where folks were having trouble getting online, and if I'm doing all my research going through a bot, or so to speak, or instant analyst, is there fear from some of the customers about the skill sets?
I think that's a fairly valid question. I think it is as much of a crutch as calculators and Excel has been to the ability to do mental math, right? Has it sort of weakened our ability to do some quick arithmetic in our head? Possibly, but it has also expanded our ability to do mathematics at a scale that we couldn't have possibly done on a sheet of paper, right? So I think there are trade-offs in that regard.
Akash, what's maybe around the corner? And I want to highlight, because you've hinted at some examples that might be actually tremendous leaps. So we started off talking about text-based analysis. I think everybody is comfortable with that. But the things that you were hinting at in terms of citing get into very, very different types of documents that might be a FEMA flood map, or it might be an electrical, transmission and distribution diagram, or land parcels. These are complex diagrams. They're esoteric. They're not text-based. They're graphical. You're interpreting what different lines mean. It seems like a huge, huge leap to go from a large language model to an agent that can read and interpret those types of visual technical documents.
Absolutely right. It is a massive leap, right? And that lies why it is one of the more challenging solutions, right? Like, as an example, as we are building these solutions, these sort of phase two solutions, if you mind, building these solutions is building them and having them work a certain way is not the challenging part. It's having them work consistently and repeatably in the way that we want it to is where the challenge comes. It 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 lends repeating. These systems are highly non-deterministic, but that is their power. If they were extremely deterministic, then we could just write, I'm sure I have done that earlier in my career, a 500 line case statement to handle every edge case. Those systems work efficiently, they don't really scale, right? So you want it to be non-deterministic, but you also want it to be deterministic when you want it to. So as an example, Jeff, the case study that you mentioned about like how we are looking at these agentic systems. So let's say a user asks, this is my particular substation and I want to figure out what are the parcels within a certain amount of radius from it, right? To be able to execute that, all the user does is ask that question in English, right? First thing the one model has to do is figure out what is the substation, fill, extract the substation name from it, and then find a similar substation or exact search in our substation database. That means understanding text similarity. That means understanding text to SQL. And that means understanding, again, edge cases and handling deterministic, non-deterministic solutions. Once you have that, then the model needs to figure out, all right, I have a name. Then there is a separate agent whose job is to build a radius from a particular area. There's a lot of different ways of doing that. If you build an actual radius and do a spatial intersection on the fly, then you might as well ask this question, then go grab a cup of coffee because it's going to take a few minutes. We are looking into some solutions like H3 indexing that allows for large spatial indexes to pre-exist. And so then what you've done is you've translated this question into you have a substation, you have a radius amount. These are two variables that go into a function whose input is lat long and distance, and whose output is a list of parcel IDs that intersect the indexes that fit with that criteria, right? And then this output of this function is fed back to the LLM. So, and it basically says like, hey, here is the list that was asked for, return this to the user, right? So the language model, if you think about it in this regard, is basically parsing the question into its constituent pieces and just triggering what it thinks is the best agent to do this job. It's actually not finding the solution for you. The last part that the LLM does in this sort of a workflow is compiles the results of the different agents in a logical manner and says like, all right, now I have this new set of information, given this lat long, given this substation, given this list of parcel IDs, here is what I can tell the user. The language model has no context on how those pieces were calculated. That's what the agents are designed to do. But that's also where the challenge and the difficulty in scaling these systems come, is because how do you ensure that the model chooses the right agent all the time? Which, like, it does a lot of the cases, but where it doesn't, that's where you have to continue to iterate, design, and improve. Does that answer your question, Jeff?
It sounds like you've broken it down into the pieces of the puzzle so that we can, it's maybe not as far off as it might feel, but there are a lot of interstitial points that need to work before that's
Absolutely.
a reliable application. But to your point, it's coming. One more application that you seem to hint at was energy trading. So are there also time series energy evaluations? Can these generative models actually do predictive price modeling? Are we going to see more of that in the future?
So one of the areas where we are using generative models for in time series is actually building the time series model from scratch. Like, it's a foundational model. Instead of text, we are just using numerical information, which is great because it makes for a much more smaller and affordable model. It does, of course, you have the nuances and complications on building the right model. When it comes to actually building these models out, I think on the timescales and the frequencies with which energy trading exists, it's going to be harder to build and maintain a model of that scale, right? But when you're looking at longer horizons, for example, if you're looking at ERCOT load for the next month, if you're looking at Permian production curves for the next year, we've done some early tests and the model seems to perform really well. These are pretty massive models. They take hours and hours to train, but they are able to build and develop on these sort of time series models and things of that nature. So again, going back to that sort of perspective of like, hey, this model can help provide uh, you know data points and fundamentals and inputs that could help inform your trade, but as the model stands today, they may not exist in the frequency and speed where you may be able to execute trades directly on them. The other part of this that I will always mention with any of these models, which I think we hinted upon earlier as well, is transformers and generative AI models are very black boxy, right? It's hard to explain. There are sort of approximations and inferences you can do to say like, hey, this is how the model does this. But if you were to specifically ask me like, hey, Akash, why did this data point predict this as its next month's forecast? I can't give you the same level of confidence I would if it was a, let's say, multiple regression or an ARIMA or like, one of those statistical models. So, which makes, again, there is an apprehension and resistance on using these systems in something that maybe is high decision like trading.
All right. There's a lot going on here. And we're getting close to time, but I have one kind of last question as we're going along here is, there seems to be a lot of disruption, and you're moving at a fairly quick pace. What are the next hurdles we need to see, or what are the gates to go through to see the next evolutions? You and Jeff talked a little bit about the incremental things, some of them done, some of them on the near horizon. What's keeping us from going faster, or are we going super fast and we're going to see amazing change in the next 12 months? But what are the next gates for this kind of technology?
I think we are going really fast, right? I think the rate of innovation of some of these things is breakneck. Truly, there are functionalities and features we developed when we first started building this 6 months ago that are now standard packages part of LLMs that had to be built out, right? Things are. Having said that, I think as you think about the gap and like what we could do to improve the application of these type of things, the models have to get better at multimodal processing, right? That's just a fundamental requirement. A lot of the challenges that happen right now, and this goes back to one of Jeff's earlier question about how do you look at complex geometries and things like that. We have to convert those complex geometries into digital numerical format, right? Imagine a world where language models are able to look at that image and process the image on the fly. That would allow us to scale application of these models much more faster. Also, fine tuning and model retraining needs to get cheaper and faster, right? If I want to,
but does that mean hardware is not there yet? Is there?
I think
is the compute there?
Hardware availability. I think the compute is there, but the compute affordability and availability, I think, needs to change, right? With the NVIDIA new Blackwell and new chips that are coming out, which are going to be faster and more efficient, I think those strides would help us a lot. Because right now, if you think about it, the whole processes that I'm defining, you start with a foundational model and then you create systems around it to orchestrate and guidelines and things like that, right? Imagine a world where you could take a smaller model and teach the model itself to perform in a very, very specific way. Every agent has a trained model specific to its task. That is something that will allow us to scale much faster, but it's really, really expensive, right? And until we get to that, I think moving these things forward will be a high risk, high reward type of situation.
Akash, this has been a tremendous journey. We covered some very detailed and nuanced energy applications, from the accessible nature of data in PDFs to now multimodal non-text documents, to thinking about time series and energy data. And you've painted a vision of where we can all be using these tools to be more efficient in analyzing energy data. That's very exciting. I'm looking forward to seeing big things from you and Enverus. And thank you so much for joining us on the show today.
Absolutely. Thank you so much again, Jeff and Chris, for having me on the show. It's a fun discussion.
For audience, this has been a great episode. I always love talking technology. I want to hear what's happening in AI. We get a lot of questions on AI. So I hope that you found this informative. If you did, take a second and hit that like button. Go ahead and add a comment. Follow us on YouTube. And we'll see you again next time on the Insider's Guide to Energy. Bye for now.